So for next topic, I'm going to show you how you can complete a square if you're given that we have the polynomial expression provided. So before I move on to the completing square in polynomials functions, I just need to do a warm-up question. So in this example, I show you the square here, and the length of the square is x plus 5 centimeters. It's a polynomial expression, so I want to figure out the area of this square. So how could I do this? So given that we have the length provided, x plus 5 centimeters, I'm going to square this expression in order to get the area of this square. So how could I do x plus 5 squared? So we learned this from math 10, a plus b squared equals to a squared plus 2ab plus b squared. So basically I'm going to replace the a with x and b with 5 to get this expression. So if I replace x with a and 5 with b, I got x squared plus 2 times x times 5 plus 5 squared. And it gives us x squared plus 10x plus 25. So this expression is my area of this square. So here's a discussion topic I want to discuss in this video. The expressions below are only one portion of the area of the square. And what number should I add if I want to complete this square? So basically I show you these expressions here, and these expressions are only a portion of the area square. So I want to figure out what number should I add if I want to complete a square. So in this example, I'm adding the b squared here, the unknown value. So why I'm adding b squared but not the b? So because I want to rewrite the expression in this format. So if I have this area format, if I want to complete a square, I need to add this number. So if I add this number, I can turn this expression to this expression. So, and I will complete the square for this example. So because I want to complete a square, so I need to add the b square here, and I want to turn this to this format. So basically this format and this format is the same. So in order to find out what is the b value, so let's first expand this term first. So if I expand this term here, I will get x squared plus 2bx plus b squared. If I expand this term, and this term must be equal to this term. So this term is x squared plus 2x plus b squared. So basically these two terms must be equal. So we see that the first term and the third term is equal in these two equations, right? So the first term and the third term is equal to second equation's first term and the third term. So the only difference is the middle term here. 2bx is different from 2x. So because I want to make these two equals, so the middle term must be equals as well. So how can I make this equal? So I'm setting 2bx equals to 2x if I want to make this equal. So if you want to solve for b, I just want to do b is equals to 2x divided by 2x. So I just isolate this number, and b gives us the 1. So what is b equals 1 tells us? So given that I have a portion expression of the area square, x squared plus 2x, so basically if I add the 1 square, I will get the area of the square, and I complete the area of the square. So the area of the square should be x plus 1, and the length of the square should be x plus 1 as well. So in the next example, this is the one portion of the square area, and I'm going to add again the b squared in order to get this format. So x minus b squared. So this term, I turn this to negative because we have the negative sign here. So basically, I want to expand this term and make these two terms equal to each other. So when you expand this term here, you will get x squared minus 2bx plus b squared. And this term must be equal to this term here, x squared minus 4x plus b squared. So we see that the x squared and the b squared is the same in these two expressions, but it's different when you see the middle term. Negative 2bx is different from negative 4x. But I need to make this equal by solving the b value. So how could I solve the b value? So I just make these two sides equal. Negative 2bx equals to negative 4x. I'm going to divide negative 2x by both sides to isolate this number. And I got the b equals to positive 2. So what is positive 2 tells us in this example? So given that I provide you the one portion of the area square, and I'm going to add 2 square here to get the complete square area. So what is the length of the square? So the length of the square, we can rewrite it as x minus 2. So the area of x minus 2 equals to x squared minus 4x plus 4. And this is only one complete square. So I'll complete the square for this expression. So this is what usually you will taught in school. So basically, if you want to do the complete square involving the polynomial expression, you will actually plus a 2. So this 2 is coming from the coefficient in the middle terms here, and I'm going to divide it by 2. So I'm going to take any middle terms coefficient and divide it by 2, and we do this square. So, and also for this one, I'm taking the middle term here, the coefficient 4 divided by 2, and we take this number and do a square. And we'll have completed the square for this one. So why is that? Why we need to divide it by 2? So basically this term here and this term here is b squared. We just figure out this one, right? So basically b is equals to 2x plus 2x in this example. If our x will be cancelled out, and that's why I got the b equals to 2 over 2, and I replace the 2 over 2 here, and I get the complete square. So basically also the same situation, the b value is 4 over 2 in this example, and the b value is equal to negative 4x over negative 2x. So the negative and the x cancel out, and we got the 4 over 2. So that's why we got the b value equals to 2, and we complete the square if I add the 4 for this expression. So basically in the fast method, you're going to take the coefficient in the middle term and divide it by 2, and we just do this square. So this is the reason why you need to divide it by 2, because of the coefficient here.